My name is Jeff Boccaccio. I'm president of DPL Laboratories. We are a HDMI certification company. We basically inspect, detect, and reject products. Unfortunately, we reject more than we detect. The interface has been somewhat of a, it's been going through some rocky roads as it begins to get deployed even more. And as it's moving into this sector, especially in the audio side, we're going to have more issues that are going to start popping up. But if you're not familiar with some of the issues that are happening over the course of the last 3 years, I'll be happy to talk about that with you during this event. But we're going to cover a lot. This event typically is about 4 hours long. It's usually an engineering level, and we brought it down to a consumer base to try to make it so that you don't get lost and you kind of understand what's going on with the interface. The idea here is to teach you about the interface. The idea here is to have you understand how to use the interface and how to pick products that you want to use the interface. I'm not here to tell you what to do or how to do it. I'm here to give you the brains so you can do it yourself. And that's okay. I'm going to have a slide on that in a minute. And so when you get through with this, if you can walk out of here today with 70% of what I tell you, I'll be very happy. We'll be doing this more in the Nordos room. We have other Joe. We have other times. Yeah. We have other times in the Nordos booth room. I don't know where that. It's in the mezzanine area. And so if you don't get it all, which you won't, there'll be other presentations going on throughout the weekend, so you can refresh yourself on it, or you can tell other people about it if they want to learn a little bit about what's going on. I think you'll find it very fascinating. I do about 75 of these a year, and we do them all around the world. So we do them in 7 different languages. So it's been around a lot, but now we're moving into another sector, which is the upper end audio side, which is this side is. And of course, whether you like it or not, your analog audio is going away. It's just going to happen. There's not much you can do about that. Nobody can do anything about it because the people that supply the media to you are all changing over. So you're going to have to change over with it. So you might as well get with it, figure out what's going on, and start adapting to the future, what's going on here. This is my opening slide, and that opening slide is a waveform. Does anybody know what that waveform is? It's an eye pattern. Very good. It's an eye pattern. We use this eye pattern to measure and examine equipment. It's not like an analog. It's not like audio. It's not like we throw a signal generator on there and do a harmonic distortion or IM measurements on it. Quite frankly, we don't give a rat's ass about that. And you'll find out very soon that under this new interface, a lot of that goes away. And you've got to be privy to exactly how you're going to adapt to it and what you do with your systems. We're going to talk about these eye patterns because I'm going to teach you how to read them. You're going to need to know how to read these because when you shop, when you buy, when you read, you're going to have to probably start looking at these and understanding what they mean. If manufacturers don't know what these are, my suggestion is to walk away because that means they have no clue what's going on in the interface. This is the meat of the interface right here, and you're going to learn it today. Now, during the I have, okay, this is going to be fun. I can tell. I can tell this is going to be fun. Nothing's gone good with me technically today. All right. I have rules. And I have a few rules that I want to cover with you before we start. And the first rule I'm going to cover with you is to turn off your cell phones. We're not going to have any time for that crap. We got to really move along with this thing. There's a lot of data we got to cram into, I think, less than an hour. So it's not going to give us a whole lot of time. Also, if you have a question and it pertains to something that you're with right now that's affecting you, ask it. If you don't figure something out that I'm going through, ask it. Because if you don't know, you're never going to get through the rest of the hour. If it's something about you, about a problem you've had, or something you've read, or you think maybe you've heard something that isn't true, I'm here all weekend. I'll be after the show, and we can talk about it then. But in order to keep things moving, you have to keep things going with that. And the session is for you. This session's for you. It's not for me. Trust me, I know all about it. I was brought in by Nordost, who is one of our DPL certified accounts that has made the mark of getting through our certification standard, which isn't easy. And they asked me to come in and talk to you. So we should thank them for allowing this to happen, because not too often you get people at a consumer level especially to dive into the bowels of HDMI. So the session's for you. Get involved with it. Yes, sir?
What do you guys certify?
We certify the integrity of all the products.
Not just HDMI.
Oh, well, we do primarily HDMI, PCI Express. We're mostly high-speed digital. We do not do, okay, let me preface that. We do not do any more analog audio. We left that a long time ago. It's just you'll see as we get through this. I have terms. We're going to be talking digital today. And in digital, there are 2 states in digital, aren't there? Everybody agree with me on that? 2 states? What is your name? Mark. Mark, tell me 2 states.
I don't know what you're talking about.
You don't know what I'm talking about. Okay. In digital, okay, you want to help us out? Give us 2 states.
Digital and everything in terms of
Ones and zeros. Okay, you see, you knew. It's okay, that's what you're here for. Ones and zeros. How about another one? Give me another state. Black and white. Up and down. Plus and minus. They're all states. You know what's interesting about these states? There's only 2. There's only 2. So I got terms. I got 2 terms I'm going to talk to you about, because we want to talk about only good things, don't we? And the first term, I call this first term good juju. We only want good juju. So now the opposite state of this would be what? It'd be a bad juju, right? Well, we don't want bad juju. See, it's so bad it doesn't even want to come up. We don't want bad juju. We want good juju, don't we? So we don't want good juju, we want bad juju. So the bad juju goes away, and that's what we're going to be talking about today. Good jujus and bad jujus. What we're going to cover today, we're going to cover some things you really need to know, like why did we end up at HDMI? Why did we leave that analog area? I'm going to tell you why. Number 2, how do we do the conversion from analog to HDMI? I'm going to show you how that's done. And you're going to be able to understand how to get through it if you want to purchase products to do that. And of course, how does the HDMI system even operate? We're going to show you how it works, so that when you do get your products, you know exactly how it's functional. And if it doesn't work, you know basically how to troubleshoot it. It's pretty easy. It's not that hard. Follow me through. We'll make it through. Everybody with me so far? Okay, let's see if we can get this thing to work. Yes, and this is a good one. And there's also how many ways it doesn't work. We're going to talk about that also. Unfortunately, that's been very high. The interface, like I said, carried a kind of a bumpy road. And it's getting better now. It's getting better now. But with better things, things happen. Okay, are you buying video today? When you go out and buy some video products, are you buying video? Okay, good. And you are David. David said yes. David is wrong. Thank you, David. But at least he spoke up. The rest of you guys are pussies. Come on, let's go. Okay, so no, we're not buying video. Are we buying audio? Are we buying audio? No, we're not buying audio.
Entertainment.
Very good. That's still not exactly what I had in my mind. But what we really are doing is what you're really buying today is you're buying illusions. We build illusions. Basically, I'm an engineer. We build products for you to buy and use. And they're cons. They're nothing but illusions. They make you think that you're sitting in music. They make you think you're in live. That's my job. And the closer we can make it to live, the better we are. That's what you're here for today. It's only an illusion. HDMI is an illusion on steroids. And when it gets fast, it gets very dangerous. Here's an illusion for you. We have a blue and a yellow. If we put red lines through that, what happens? We get magenta and orange. It's an optical illusion. Whether it's optical or whether it's audio, it doesn't make any difference. It's still an illusion. So after 60 some odd years, a big change had to take place. We had to move into a different illusion. In our world, we call it the Big Bang in the video cosmos. And that Big Bang would be what? What do you think that would be?
Digital.
Digital? Who said that? Mark. Excellent, Mark. Wrong. But still, that's very good. That's good, Mark. I love it. He's almost right. Come on, guys. HDMI, no. No, the big deal was high-definition television. We changed to high def, and this was a whole new illusion. You don't get it. I was part of the rollout. I did it for 7 years. Trust me, this is not something that happened overnight. It was a political nightmare, and it was because we got frozen in time in NTSC and PAL. When it was designed in 1938, we basically never went anywhere after that. And the FCC realized that, and the Founding Fathers realized that, and they weren't going to get caught in that again. So after 60 years, we finally broke out of that frozen state. And that's what we're talking about with HDMI. So this would bring big demands now, more than just video. It would also bring not only high-resolution video for robust, but new audio, new signal processing, a whole new audio environment you've never even tapped into. It's all coming your way. It's all coming your way digitally. It will not be analog. Also, there has to be conditional access. You'll find that most of your product that you listen to, the things that you're getting today, in the next 10 years will be by subscription. Blu-ray players, DVD players, they're going to go away. It's history. It's like Netflix. You know, see what happened to Netflix, right? You know who Netflix is, right? Everybody know who Netflix is? Who doesn't know what Netflix is? Okay, I guess everybody is. Netflix is a subscription service. It allows us to get movies on the fly. Now, the quality isn't perfect, but they're getting there. Music is easy. It's going to be subscribed, so there has to be conditional access so you can talk. Can't do that with NTSC in analog. Also, we have to have intelligence. There's got to be some brains in this thing because there's content protection. There's different resolutions. There's different audio schemes. All of this has to be detected and determined by each TV and by each source every time you turn it on. It's not like audio. You know, you put a record on and put the arm on. I mean, come on, I grew up with that, guys. I'm not exactly young. Been around. But I've learned to grow and adapt. As an engineer, I have to. And the stuff that's coming next year is going to blow your mind. It's going to blow your mind. And of course, we have content protection. And content protection is for anybody, audio, video, and they want their piece of the pie. So all of this stuff is going to be content protection, and that's got to be done through HDMI or some service, but we can't do it in analog. And the last thing is we want to be able to expand this later on. We want to go beyond this in 5 years, in 10 years. We don't want to get into a bottleneck we got before with NTSC. So it all had to be done, and it all had to be done digitally. And the whole process had to go from analog and eventually all the way to digital. And we're going to talk about that conversion process. And to do that, we're going to focus on bandwidth. Everybody know what bandwidth is? It's frequency response. In the audio industry, what do you deal with? 20 to 20K, right? No. That's not what it is anymore. Today's bandwidth starts at 0 hertz and stops at 1.5 gigs. Gigs! Audio is nothing. Audio is here. A teensy-weensy area there, that little audio. That's the world and spectrum we live in now. Not next year. It gets worse next year. Does everybody hear me? I just want to make sure everybody hears me. Mark, you're okay, right? Okay. I hope so. Bruce, you're with me? All right, here we go. So, if we look at this, we know that we also on our RF side, we have our satellite TV, doesn't it? All right, DirecTV, all that stuff. That's all happening at 1.5 gigs and above, something like that. So overall, in the consumer range, this is where we live. So we live in an analog, or we lived in an analog world, didn't we? And in the analog world, when we look at to determine how to build these products, we do it with signal waveforms. We've always done it with signal waveforms since 1922. This is not new. These are waveforms that look like this. Does anybody know what that is? It's a sine wave. So you're not so stupid, Mark. It's a sine wave. And sine waves have their own characteristics. One is that they use amplitude, right? There's an amplitude component to it, and there is a speed component to it. And when that's done, this particular waveform is 20K, 20 kilohertz, the top end of your hearing range. Now, if we wanted to cut that in half, we could do that by doing this, can't we? We just cut the sine wave in half. Our amplitude is the same. Our speed, however, is now 0.5x, or half. What does this mean? What it means is amplitude gives us level or gain. Speed gives us tone or frequency. Does everybody follow me so far? Very good. How about distortions? And oh, by the way, all of these are measured analytically. All these measurements are analog measurements. We don't do any digital measurements. That is a fallacy. So when we measure analog, in this case, we use analog test equipment. Okay, how about the distortions, right? Analog's got distortions. It's one of the things you try to buy for better equipment, don't you? Here's an example. Here's our sine wave. Let's throw in some harmonic distortion. Here's harmonic distortion. Everybody familiar with harmonic distortion? Right? It's a spec that you look in your amplifiers. When you buy your amplifier, hopefully you're looking at that, because it is important. And that particular distortion is one way, but also we can take the same distortion and square it off. And when we do that, we're looking at intermodulation distortion, or IM. So in good amplifiers, you'll notice that the spec will say total harmonic, X in percent. Intermodulation, X in percent. How many people don't know what IM is? You don't know what IM is? Okay. Anybody else brave enough to raise their hand? Thank you. Nobody? Let me review real quick. IM, intermodulation. What we do is we take an amplifier, like a power amp, and we're not pretty. I'm not in the business of seeing how bad something is. I'm in the business to see how good it is. So I push the crap out of it. And when we do that, we actually hit it with two tones, typically one at 4,000 hertz and another one at 400 hertz. And we change the ratio of gains. And then we put them through test equipment, and then we demodulate it out to see what the amplifier did to those two tones when they were being amplified at the same time. It's called intermodulation distortion. It's a great spec. It really shows up in square waves. So when you use power amps that, if they don't have a really good overall dynamic range and we go into square, it shows up in IM badly. So these distortions are done analog, and all of them are measured in percentages. And that percentage gives us quality, doesn't it? That gives us the quality of what we're looking for, right? When you buy your amplifiers and your speakers and all that good stuff, if you have good spec, you're going to have good quality, right?
Not if it's a tube amp.
Not if it's a tube amp?
No, they have high THD.
They do have high THD. So what do you think? You know what? That's another subject. We can't do it today. But I can talk to you about that for hours.
Sound good.
I'm glad you're happy with that, because you're the guy who's important, not me. I'm not here to talk about that. So we now live in a digital world, and things change. But you know what? We still use single waveforms, but we don't use sine waves. We use square waves. And guess what? They still have amplitude. And guess what? They still have speed. And you can still cut them in half. That last one was 20 megs. This one is same amplitude, same speed. This one here is 10 megs. 10 million. That's our low end in our world, 10 million. And you guys are pissing and moaning over 20 kc. And that's another art in itself, by the way. I don't want you to make you think it doesn't make any difference. It makes a lot of difference. And it's a whole new science. But this is a different science. And this is where everything's coming from. And if you notice, the amplitude is still level and the speed is still tones. But you know what? What would that sound like if we played it? If we brought down to, let's say we brought that down to 1,000 hertz and we put it through your system, what would that sound like? Anybody want to give me a graphical expression of what this would sound like?
Sound like a modem.
It would sound like shit. That's graphical. It wouldn't sound very good. It would sound like a modem. That's very good. You know what he's talking about? He's talking about FSK, right? FSK is the modem modulation scheme that we use with fax machines and stuff. It's called FSK. Everybody get that? We use this data as a conduit. We don't listen to it. We don't watch it. It's only a conduit. It's a pipe that we use to get something from point A to point B. Zeros and ones, absolutely. Good jujus and bad jujus. We can also get distortions on these, like this. See these trapezoids? This happens over speed. This happens over length. This happens when capacitive loading comes in, or inductive loading comes in. When you get up there in frequencies up above a gig, or even actually over 100 megs, this will come up. And that's the way they'll look. And actually, that's actually a very good picture, by the way. That's actually a very good waveform. But they're distorted. But, you know, like anything else, it's also measured in analog. But you see this performance? The percentage? You know what it yields? It yields reliability. That's what we're talking about. Not quality. Or very little with quality. And I'm going to show you what that means so you know where you are when buying HDMI products for quality. Okay, analog performance curves. This is interesting. Let's look at this curve. Here's our good jujus and bad jujus going up. So the higher the good juju in performance, that's good, right? Bigger is better. But the deeper we go into the failed region, we go into more bad juju, don't we? We don't want to be in the failed region. So let's look at analog for a minute. Here's the analog waveform. These performance levels, by the way, could be either by distance or performance, which means that the product was not made very well. Doesn't matter. This is what the curve looks like. It's analog. So in other words, we started with a high performance, maybe down here somewhere, but either by distance or poor engineering, the performance goes down, and it finally gets down so far that it finally goes into the toilet to bad juju. This area I is the quality area, the analog quality region. And you're going to see this for your own eyes in about 2 minutes. Now, if we look at the digital curves and digital performance levels, right? We see we have our same curve here, but you know something? The thing changes. We still deal with distance and performance, but now the curve looks like this. Anybody see that before? Notice what happens. Thank you. What is your name?
Goose.
You have to think about that a little bit, huh? Okay.
I say which one to give out. Really.
Okay, Goose. You see what's happening here? We have all kinds of performance, don't we? But when it falls big time. There's not that gradual slope that analog gives us. So we can get our digital reliability region. So where's the quality? The quality is right up here in this cliff. This is called the digital cliff. And that's exactly what it looks like, isn't it? If we look at that cliff a little closer, we'll notice that in that area right here, this is where all the quality is. That's what you're buying. That's where you live. Or better. You get into that cliff too far, and your history. And the real problem is you can't even detect it. You can't even troubleshoot it. In fact, in most cases, you can't even measure it. I can, but you know, we got $1 million of test equipment sitting in our facility to do that, and you're not going to go out and get that stuff. So you have to go by companies and what their integrities are and what their specifications are. And I'm going to teach you these specifications. So analog performance, we have a huge effect in quality, but not so much of an effect in reliability. But in digital performance, we have a huge effect in reliability and not much of effect in quality, or a lesser effect in quality. Everybody still with me? Let's look at television. What is that? All right. Why? Why did we end up with 4:3? Does anybody know?
CRTs are round.
Mark, you're so good. Does anybody know the correct answer? I love you, Mark. You are my man. I'm getting too close to you. Huh? Because somebody picked it. No. Do you know?
It's a modulated, it's an equal division of 60 hertz, no matter where the analog equipment could work.
You're close, but not there. Very much more obvious. You got to be an old man like me. And Joe, don't answer this. And Eric, don't answer this. These are two buddies I know. They know their shit.
The original aspect ratio for early films.
Absolutely. What is your name? Rick. Excellent, Rick. Yes, it's an early aspect ratio for what? 16 millimeter stock. It was in the 40s this was developed. This was considered high def. 16 millimeter film. And guess what? It had parameters, didn't we? We had 640 by 480. We never got that. That's a fallacy. We never got that. The actual content of this, when you multiply it out for square, it comes out to be about 300,000 pixels. That sounds like a lot. You know, that's a lot of pixels. But you know something? I'm going to show you something. I'm going to teach you a rule. A very easy rule. You ready for this? I call it the rules of hundreds. For every 100 lines of resolution you want, you must support it with 1,000,000 hertz in bandwidth. Should I say it again? What is your name? Grace. What did I just say? You did not get it, did you? I've done this many times. Come on, guys, we're here for a good time. So, what did I say?
For every 1,000,
No.
For every 100 lines
Of resolution
you need 1,000,000 hertz.
to support it. Does everybody get that? Okay, here we go. So let's yes, sir. You didn't hear it. Okay, well, I'll say it again. Okay, did you actually get it? You didn't get it. Well, I got myself confused. For every 100 lines of resolution you want, you must support it with 1,000,000 hertz of bandwidth. I'll show you in a minute. So here we have this. So we have 640 horizontal lines, don't we? It's all horizontal, by the way. So Grace, talk to me. What's the bandwidth of that thing? 640 lines. Do the math. What? Who said that? Mark? Oh, Mark, he's right. 6.4 meg. We need almost 6.5 meg to take care of that envelope. We never got that. The FCC only gave us 6. What a spoof. In reality, it got even worse because of Kel. How many people know about Kel factor? Wow. Rick, you know about Kel factor, huh?
Worked in broadcast TV.
Oh, you did? Okay. Well, Kel factor brings us down, actually, to about 338 in reality. And I'm not going to go into Kel factor, but if you anybody want to talk about it, I'll talk about it later on. But this is very important to know because it's like that all over the place. Because, you see, in our old broadcast system, we had 4 megahertz of actual bandwidth of modulated envelope, and we had a meg of bandwidth on either side of sidebands to protect ourselves from the adjacent channels. So we really only had 4. So how many lines do we have, Mark? How many lines? Oh. Huh? 400. Everybody get that? Did you get that? You're sitting right next to him. You think I'm not going to pick on you? You're Dustin, huh? You're dead. Everybody follow this? 400 lines. All right, let's move on. Here's a frame. Here's our buddy James Bond. It's in color. This is a pretty good picture here. I'm going to show you what analog does. But to do that, your eyes have to be in good shape and you got to see well. And to see resolution well, I'm going to convert this to black and white, like this. So now we got black and white. We got 450 pixels horizontally. So, Dustin, what's the bandwidth?
4.5 megahertz.
Is he right, Mark? Yep. Ringo. Everybody get that? 4.5 megs. So we got 4.5 megs. Let's drop that sucker to 350. You ready? 2, 3, go. What happened? Come on, guys. You're supposed to be the guys in the high end. Slightly softer. It's like a veil was put over it, wasn't it? Very good, Mark. I'm impressed. I'll get you on something. Dustin, very good job, by the way. All right. 300, 3 megahertz. Here we go. Oops, I went too fast. 250. Let me go back to 300. My transmitter broke, so I got to use my mouse. 300. So here's 300. Here's 350, right? Here's 300. You see what's happening? We're losing that resolution. Look at his hair. Look at his creases in his face. All that resolution is being lost. By the way, the same thing happens in audio. 250. Getting pretty muddy, isn't it? You know what's really killer about this? That's what we had with VCRs. Look how far we came, huh? 250 is all a VCR would produce. But you know something? It worked. The quality wasn't there, but of course, if it was a customer talking to you, he'd probably tell you just need cataracts. You know, and walk away. 200. 150. You ready for this next one? The human eye is not linear. It goes into the duper when it's not happy. Bad juju, 100. Yes, this is bad juju. You know what's interesting about this 100? Component video, the color of component video is only 100. And that's what you watch. Remember I told you how we con? We con you. There's no resolution in that TV set. All the resolution's in the black and white, in the luminance. It's not in the color. There's no space. We only had 400 megs, right? 4 megahertz of bandwidth. The only way we can get color is if we put 4 megahertz times 3, right? That makes 12. 12 doesn't fit into 6. It would never work. RCA developed this in 1956 called Color Track. RCA. That's how long component video has been around.
What is component video?
Component video is basically a way of taking red, blue, and green, the 3 major colors, okay, and then manipulating it off of white. Yes, those cables, right. Mm-hmm. Now, everybody follow me so far? Because now we go into high def, right? The rules change, don't they? Rick, come on, Rick, this is your baby. What's the bandwidth, Rick, on this one? Don't tell him, Mark. Rick, what's the bandwidth? Nobody? Anybody want to? Not you. Anybody else want to make a comment on this? Guess. 14.6. What's your name? What's that name? I'll call you it. Jesse. 14.6. That's incredible. You're wrong. How'd you come up with that number? I mean, would you pull out of your ass? People, 100 for every, right? 19.2 megs. Roll it off to 20. Make it easy. So we got 20 megs, right? Far cry from 4. Oh, let's look at things here. We have to double the horizontal speed. It was 163.5. Now it's 30, half of that. 31.7 or something like that. And if we look a little closer, we have 2 million pixels, don't we? But it gets even worse because each pixel is made up of 3. They're called triplets. Go home tonight. Look at your screen. Take a magnifying glass. And you'll see these things are actually white. And they're made that way by using red, blue, and green. And they have 256 stops for each color. Multiply that times 2 million. This thing is screaming. 20 million? Ha! Let's look at that. Let's look at where 20 million falls in our spectrum. So here's our 20 million. Oh, hold on while I yawn. Where's audio? I don't even see audio. It doesn't even exist. You see where I'm going with this? What I'm telling you is we're going to be working in a whole different part of the spectrum. And whatever you know now, you've got to start learning more if you want to stay into this wonderful, wonderful opportunity of hi-fi and video. You got to get on the stick and watch. It's a lot of fun. It's a lot of fun, and the level of enjoyment you'll get out of this is absolutely never ending. Okay, component video. This goes back to your question. So we have, here's Y, that's luminance, that's black and white. red, that's red minus. And blue, that's blue minus. Component video. So if we took those attributes and we looked at them and said, okay, we have luminance, and we have red minus, and we have blue minus, these make up the component video element for video. Now watch this, because we're going to start moving into audio very quickly here. I call it the component video triangle, i.e. Bermuda Triangle. And with this triangle, notice we have a yellow, that's our luminance, and that yellow produces what? It produces black and white. So here's a black and white picture we have here. Now if we want some color added to that, we add a little red minus, only that gives us cyan. What we're really doing is we're subtracting the color out of the white. See, RCA was very smart. What they did is they said, look, we want color, but we can't do R, G, and B and add them together. So instead they said, look, we know how to make white. That's easy. And we know that we need red, blue, and green to make white. So why don't we just subtract it? Which is exactly what they did. So by subtracting red, we get cyan. It's kind of like we got this bucket of paint, and we went in there and pulled all the red out of it. The paint would turn to cyan. Same thing would happen in blue. If we add blue, we get full color. If we take all the blue out, we get another color, which is yellow. By manipulating these different bands, we can do funny things, which RCA did. But if we lower the resolution of this or the quality of that video, look what happened to the screen now. It gets all fuzzy, doesn't it? Just like our James Bond. So what do we learn here? We learn that analog quality is very susceptible to its performance level. As the performance level goes down, the analog quality will go down. But it takes a lot to kill it. I'd have to pull that yellow out. And if I did that, the whole thing goes in the toilet. And we move to the dark side. So, what does this mean? Well, it means we got to convert it to digital. We've got to make it go with the new HDTV rollout plan. All of it. Analog's got it. All the audio's got to be converted. All the video's got to be converted. And it's got to be seamless. This was not seamless. Trust me. If you knew what went on for 7 years in Washington, you wouldn't believe it. The political crap we went through. But we do that with converters. So we have a red, which is 8 bits. We give it 8 bits. Green, 8 bits, and blue, 8 bits. So let's look at that a little bit. How do we do that? We do it with analog digital converters. You guys are familiar with that. There's all kinds of converters like this around. And we did this for a long, long time. We actually did it with a thing called staircase generators. Let me show you how this process works, so that when you're looking at A to D converters or anything having to do with those kind of conversions, you know exactly what's happening. Basically, it's this. We have a line down here that's time, and we have another line up here that's level. This is amplitude of the square wave. This is speed of the square wave. The diagonal is the analog attribute it yields. Watch how this works. I'm going to put a 4-bit word. Anybody, you guys must have heard this before, right? 4 bits? Everybody hear about 4 bits? You don't have to know what it is. You heard the term, right? Everybody? Say yes. Thank you. Yes. So 4 bits. If we take 4 bits and bring them down here, that's 0, 0, 0, 0. That makes what? 0. That's our analog number. Let's do another one. Here we go. 0, 0, 0, 1. That makes a number 1. Let's do them all. Here's all of them. We go all the way up to 100, we get 64K resolution. This is what happens with DVD players when you're playing music. You know how they talk about the sampling rate? It all has to do with this staircase. The more coarse that staircase is, the worse it sounds, primarily in IM, intramodulation. This would sound not so good, especially in the upper high frequency response. But if we move that to 8 bits, and change the resolution, what happens? A lot of good stuff happens here. Because now that square turns into a little guy. Another little guy. Another little guy. All of them. Now we've got 256K. Look at the resolution now. Far better than we had before. So by increasing that bit size, we can gain tremendous resolution for both audio and video. That's what HDMI was looking for. It increased the bandwidth dramatically. Now let's look at these numbers. And you're going to be very interested to see this. Here's our 8 bits for each color. We put those through a little adder. We put them together. They make 24 bits. Everybody found this so far? Right? 8 times 3 is 24, right? Then we take that and we multiply it times its horizontal frequency. What was that horizontal frequency? Rick? High def? 19.2. Let's call it 20. 20 megs. 20 megs. Put those together, and you know what you get? 480 megs. Now let's look at our new spectrum. Where were we before? Now, this is where we are now. We're in a whole different environment. Totally out of your range. And you know what? That's old. That's HDMI Rev 1. That was years ago. Now we're operating under 1.4, which brings us all the way out to 900. So we're operating in a gig. And to think that we thought it was so tough being down there at 20K. Does everybody understand what I'm trying to say here? It's a new world. You've got to get on the stick when you start thinking and buying these newer products. Because these manufacturers have got to work in a new world too. That means new engineers, new test equipment, new formats, new specifications. All this stuff is new. And in order for them to get the quality that you're demanding, these guys better be on the stick. And what I do is I take that stick out every day. And somebody comes by and does a bad juju, bang, and I whack them. In a good way. Yes, sir.
What does HDMI stand for?
High definition multimedia interface. And you said, I'm sorry, I interrupted you. Everybody get that? I'm sorry, I should have said that before.
Does it mean more than a cable between
It's one cable.
sources?
It's one cable between source and sink. Okay, we call them sinks, not displays or speakers.
HDMI was developed at the same time that high definition television and all these were.
Actually,
Come after.
it was actually done before it. It was done on a DVI. Anybody here DVI? Okay, what do they use? Used for computers, right? In the computer range, DVI was it. In fact, HDMI is exactly the same thing as DVI. The only difference is the connector. Yes?
Doesn't HDMI carry more than DVI can?
Does not. It does not. I know you're going to say, doesn't carry audio, right? No. What?
HDMI can carry Ethernet and
1.4. Thank you. You're right. You're right. And actually, a DVI could do that too, because the only difference between 1.3 and 1.4 was the way the wires were twisted. The actual cable is the same. That's a long story. If you want to talk about it, let's do it after the show. I can't go there right now. Huh?
Is the connector the same?
The connector's the same. In fact, what they did is to consumerize it for you guys, they took the DVI off because you had to use those nuts and screws to put it on, and they put on the HDMI connector. That's why they came up with that. Any other questions? Goose? I'll cover that in a second, Goose. Yes?
Are we going higher than 1.4 soon?
You're breaking my story. You're ruining my whole thing. Will you shut up?
I will.
All right. So, digital integrity. Now we're going to look at digital integrity rather than audio integrity. Now watch this. This is cool. This is 480. 480. Low end, right? We got 900. More than adequate. But what happens is we lose it. When we lost James Bond, what happened? It got fuzzier, right? Got fuzzier. This is what happens as we lose it. Nothing until it gets into the dirt. And we start losing bits. And we start getting pixels that are missing. We lose audio. We lose definition of audio. All this stuff happens right at that knee. Remember that knee I showed you? That's what all this crap is going on. And then if it goes too far, we lose it. There's no safeguard. It goes dead, that puppy's out. And you'll never figure it out. It's not like analog. So you don't want anyone getting close to that knee. How does this work? HDMI works as a collective. That's the difference. It doesn't work with, I'll use a little bit of this and a little bit of that. No, it has this collective. And this collective has 5 attributes that makes it work. And if you don't have these 5, you don't get any audio. You don't get any audio. I'm not talking about bad audio. I'm talking about none. Okay? Here we go. It needs video and audio integrity. It's got to be there in the envelope. So there's got to be some content for sure. And that integrity better be good. We're going to show you that. Also, we need timing. When we're traveling at 3 gigs per channel, let me tell you something, puppies. We're down to 112 mics, picos. We operate in 112 picoseconds in speeds. That's the difference between each wire. They can't be more than that off. Or you'll start losing quality and you'll go into the dumper real quick. It's not like analog. You can be a foot off and it'll work. The wavelength of analog is so big, I mean, okay, I'm not going to go there. Okay, here we go. Here's timing. Then we have, of course, intelligence. Remember I told you about that intelligence we needed? That's on the wire, but it's not on the video. It's a separate channel within the wire. And that channel better operate right or you're not going to get the integrity or the quality. And we have a power supply in it. There's power in this wire. And HDMI gave us a very limited supply line. I'll show you that. And we have a Hotplug. This is a trigger that goes on the display so that when your source, your Blu-ray player kicks up to start playing music, right, let's say through your DAC or something like that, that DAC better respond with that Hotplug. All right, it's never going to work. Yes, sir.
How many wires are in there?
19. Yes. Now, that's a little bit of a fallacy because 5 of those wires are grounds. And a lot of people just comment the grounds. So you can take 5 off and get to 14 real quick. And then one of the wires is used for remote control. Another one is used for Ethernet, for what Goose is talking about. Okay. We'll go through that a little bit. They all depend on each other. You lose one of these, you got no music. No party. No go Juju with the wife. Okay. Come on. Oh, thank you. These are collectives. Look at this collective now. Here we got our timing and our voltage and our DDC. All this stuff's in here, right? You take one of these out like that, and the whole thing just goes right into the toilet. And guess what that produces? That produces bad juju. We don't want bad juju, do we? We want good juju all the time. So, what does this mean? This is what the inside of that HDMI looks like. Now, there's not 19 in there. I made them easy for you to read. But you see those TMDS channels? These are the ones that carry your audio and video. This DDC line, that's the intelligence. This TMDS clock, this is the clock channel. This is serial, by the way. This whole thing is a serial interface, not parallel. And it's got 5 grounds. I'll tell you about.
How does it get 7 channels?
If I tell you that, I'd have to kill you. It's processed. It's all digitally processed. It's a long story. I can't do it now. We should do that sometime, you know? We should do a Dolby presentation. That's 2 hours, easily, 3 hours. Long story. Okay, performance of the collectors. Each one of these has their own performance levels. Voltage, we have timing, we have DDC lines, we have our voltage, and we have our Hotplug. All of them have a particular performance level. And they all have to operate within these HDMI windows. If you don't operate in that window, you're out. You're out. Now, this is where it gets pretty interesting because this is really a DNA of each product. Every single product's a little different. Whether it's a cable or a Blu-ray player or an amplifier or a preamp, they're all a little different, and they hold their own DNA or performance signature. This is what you have to watch for when you're purchasing products. Let's take this window away, and let's talk about the Hotplug for a minute. The Hotplug is basically a trigger. What it does basically is it takes a sink and a source, and it drives them together. So from the sink, in this case a display or a preamp, it takes it. Did it change? It did. It takes voltage and pushes it down the line. But you see it's 2.5. It can never lose more than 2.5 from 5. Never. You lose that 2.5 volts, you're out. It's all with reliability now. There's no quality here. This is all reliability. Okay, what about voltage? Let's look at voltage for a second. This is kind of interesting. Voltage has the same thing. It's got a source and a sink, except now the voltage goes from the source to the sink, or the Blu-ray player, or the cable box, or whatever you're using. Every time you turn your system on, it turns on that 5 volts. This is more critical because under HDMI rules, you can't lose more than 0.3 of a volt over that wire. That's 300 millivolts. That's very small. So you think about running 10, 20 meters. Good luck, Charlie. Guy better have made that cable correct. And primarily, it's in the gauge and the quality of the wire that's inside. It's all reliability. And then, of course, we can take our DDC wire out. Okay, now this is an interesting one because it's intelligence, isn't it? And that intelligence, okay, yields loading factors. This is where capacitive loading can come in and cause errors. This is only happening at 100 kilohertz, by the way. Very, very low in our world in frequency. But when that capacitive loading comes in, things happen. See these square waves I just showed you? These square waves is what the intelligence channel reads. That's the language it reads. As long as you got nice square waves, everybody's happy. That means you can get good content protection, you get good EDID, you understand what your Dolby is or what kind of sound quality you're going to get. All that happens with this square wave. But because of capacitive loading, which happens on circuit boards and cables and connectors, they'll get distorted like this. See how the front end's getting rounded here? Now it gets even worse. This is another one. When they get too far gone, that won't read anymore. Or it'll read intermittently, or they'll read the wrong one. And all of a sudden, it's either dead, looks and sounds bad, or it comes in and comes out. You'll hear the audio come in, it'll come in and out. So this is a quality and a reliability issue. Now, we also have timing, and in timing, I told you before, we've got to be careful. We've got to be less than 2 nanoseconds apart for every one of those channels. Nano. Teeny. Let's look at this a little bit. It's definitely quality and reliability because as the timing gets in error, we start getting bit errors, don't we? What bit errors, what does what? It starts pulling out pixels. Without pixels, without data, we lose quality. And audio is part of that because the audio is superimposed and multiplexed on the video in HDMI. There is no audio channel. There is no audio cable. It's all superimposed on the same bus. So what you get with video is what you get with audio. Understand? What does that look like? Here's a racetrack. I've made up this racetrack. Over here's the finish line. So if I took all these and I raced them down the track, they'd all get to the finish line. Bang! Who got there first? Green. Who got there second? Red. And of course, our good friend blue got there last. But you notice, that's bad juju. And you'll notice that it's 50% off. It's out. The unit would never work. You following me, everybody? Okay so far? Gets juicier. Yes, sir.
Can you have audio without the video?
Absolutely.
Video to black.
I'm sorry, what?
Video would be black.
Black screen. Or blue, depending on what they're using for a screensaver. Okay, we're going to look at video now. This is good because in video we have a source and a sink, same thing. Now we have still 3 video lanes, but we have video losses. When we're running video at 3 gigs, it doesn't take much. As the wire gets longer or if the guy doesn't know what he's doing, the video integrity goes to shit. I'm going to show you that in a second. And what is it? It's quality and reliability again. We have bit errors or it'll go dead. All of these 5 attributes have to be maintained. And they have to be in the upper limits. And so many don't do this. So many. Yes, sir.
So in other words, these people that are out there saying, well, HDMI, it's either on or off, you don't have to spend a lot of money. The cable doesn't need to.
They're smoking something funny.
Yeah.
I see it every day. I mean, last week we got, what did I say, 400 and something cables last weekend. And I'm going to tell you, I could show you 400 and something different cables.
I mean, they're selling them for 6 feet for $3.
I know. Go for it. You get what you pay for. And sometimes you don't. It depends so much on the quality of the manufacturer. Let me see, what was that last slide? You screwed me up, baby. Where was I? Oh yeah, right. I'll give you the waveforms, right? Okay. Okay, let's go to the waveforms. So now we're going to go into digital waveforms. This is the live pattern I showed you earlier. Now you see that thing in the middle, that blue piece in the middle? That's a spec. That spec is given to me by HDMI. I build that into Tektronix. I use Tektronix equipment, and our Tektronix has an ability of building that mask right on the screen. And we use that mask as our governing line, because HDMI tells us cannot go below this. So what we do is we have a thing called a mask margin error reader, so that we can actually take this thing, it's with this red. You see that red? This is the difference between hitting the eye and hitting the mask. And it reads it in percentage. In this case, we have 50%. By the way, 48%. By the way, 50% is the maximum we can get out of the tech. So that puppy's doing really good at 48%, isn't it? But here's another one. Peak to peak is 800 millivolts on this particular one. The actual rail voltage on this is a volt. The sweet spot is typically between 600 and 800. Here's another one. Good juju or bad juju? Hello? Who said that? Thank you, Goose. Did everybody see that? That's not good juju. Let's put a mask on it. We bring a mask into it. We only get 2% mask. Look, we're almost close to the trash here. We're going to start losing bits. You want to stay far away from that. It's like the plague. That's about 10 dB down. You get 10 dB down on a cable, you're out. Oh, here's another one for you. Remember the rules of hundreds? Here's the rules of cables. If you're operating about 3 gigs and you're running anywhere between 24 and 26 gauge, you're going to lose about a dB for every meter. Listen to me, people. 10 meters is your max. And even those don't make it. Don't let someone tell you they can do 30 meters unless they've got some active electronics with it. It will never work. We see it every day. Now, I know what you're going to say. I get guys that say, yeah, but I bought a 50-footer, which is, I don't know. What's that? 20, that's 25 meters, isn't it? Yeah. So I got 25 meters, and it plays my TV 5. Well, sure it does, because you're probably playing a Blu-ray player with roll res, and it's only operating at 165, or half the envelope, which is 400. Remember the 480 megs we had before? I said if under 1.4, if you're running 3 gigs, which is what the new standard is, it will never make it to 10 meters. Yes, sir.
What would you recommend as the maximum?
Maximum what? Distance? 7. 7 meters. That's about 21 feet. And that's if it's good, Mark. I mean, I just had these ones that just came in, we had 5 meters in the toilet. And you know what? These things were 24 gauge. They were like pipes. You'd think they'd do so good. They sucked. And of course, the manufacturer doesn't know. They buy them from China. Everything's bought in China. So what they're doing is they're giving you claims. There's no spec. These manufacturers don't even know what that eye pattern means. You know more than them. They just buy it from China. If they say, oh, Rev 1.4, okay, they believe them. And they put it on their packaging, and they say 3D. I love it when they do that. You know, this 3D thing just came out, this new 3D? Well, everybody thinks it's so cool. You know what's cool about it? There's 11 different 3Ds. And they're all at different bandwidths. So what does that mean if they say it's 3D ready? For what? Do you know there's a 3D at 480? Did you know that? You don't need much. Watch what you read. Yes, Goose, what?
It's just like putting Windows 7 ready on a monitor.
There you go. That's exactly right. All right, this has got 200 millivolts full scale. See, we're right at the breach. The breach mark in this is 150, by the way. You go to 150, you're out. This thing's at 200, too close. Here's something for you. Here's 4 eye patterns. You be the judge. Here's some masks. You be the judge. Is that good juju or bad juju? Bad juju. Everybody should have said that. I'm going to give you another chance. I'm going to say it's bad juju. How about that one? Is that good juju or bad juju? Come on. Bad juju. Why? Why? Right here, right? That's capacitive loading. Remember, Capacitive loading leads. Inductive loading lags. It's leading the mass. That's why it's doing that. You never want that in your system. We see these every day. Every day. That's bad juju. How about this puppy? That's what you're looking for, right? Nice, clean, symmetry, beautifully done. This is cleaner than crap. You want to hear some audio now? How about this puppy? That's bad, huh? Yeah. So you see what happens here. It's just the dynamics of the, and it's all analog, remember. We're measuring this analog, not digital. Look at this. This is 3 waveforms on top of one another off my oscilloscope. This is back to timing. Remember how the blue was off? See, we have red, green, and blue. Pretty bad. Does everybody get that? See what's happening there? We took 3 and put them on top of one another. And now we can synchronize them so we can see them. In this case, it was a cable, yes. But this happens with Blu-ray players, too. I'll tell you a quick story. Oh, yeah. Quick story. So we do things called PDRs. The PDR is called the Provisional Design Review. So let's say a manufacturer, company X, and that guy decides to send in something for us to test for them. And a lot of people do that. And they either want to make sure they pass HDMI compliance tests, whatever, you know. This one manufacturer had this fantastic Blu-ray player, CD audio. And it was $2,500. Expensive machine. And they couldn't get it through ATC. So they tried for 6 months, they couldn't do it. They sent it to us, and then we looked at it, and when it came into the office, it looked dynamite. And this was beautiful. I mean, it had gunmetal front. And, you know, you open the drawer up, it sounded like a Mercedes, you know, that nice ka-chunk. I mean, it was just balls. This thing was great. So we finished this thing off, and when we went to put our test disc in it, it was so bad, I could see why it wouldn't pass ATC. It would never pass. So we took it out, and we figured out when we took the cover off, it was very obvious. They built the board wrong. They used the wrong material. They put the parts in the wrong location. And in most cases, they had bad power supplies. They just didn't think it through. The Chinese just don't do that well. So we wrote a report, which we always do. It's a 12-page PDF, and we ship it off to China on Monday. Did you get that? Monday. The following Monday, I get a DHL package in. I never get DHL because it's only international. And I open it up and I get a new board. Only the Chinese can do this. I don't think these people ever sleep. I really don't think they sleep. I opened the board up and it didn't look any different from the first board. They didn't listen to one goddamn thing I told them. But I put it in because they wanted me to do another PDR. A PDR is $1,500, by the way. So every time we do a PDR, it's $1,500, right? Yeah, it's not cheap. Well, to them, that's cheap to them. But for us to maintain and do what we do, it costs that much. So we put it in, and it's the same way. So I wrote a report back and said, read the last report. Just follow. I even sketched out the damn board for him. I went, what do you want me to do? Go over there and build it? And so a week later, you know, every week, this went on for 7 weeks. $1,500 a whack. 7 weeks. On the 7th week, they actually made it over the blue. But you know what? They only made it over the blue like that first one I showed you earlier. You know the one that was in the corner up here that you hit bad juju? That's how good it was. So they called, every week they called. And they said, oh, did we pass? And I said, you made it. Oh, great, we're going to ship it. No, you can't do that. You got a $2,500 machine. People are going to think it's good. They didn't care. They took that baby and off it went. A year and a half later, they did really well with it. They're very pleased. They only had a 40% failure rate. That's the truth. And they were very pleased. They don't care. They want to ship product. Any product. Yes, sir.
How do we know which cables are good? Do you guys publish this?
We do. We publish on our website, and I'll show you that. We have about a half dozen companies that are now certified by us. We've had a bunch come in. 104 came in. We have 12 that passed.
My Blu-ray player has an optical output for audio.
Yeah, that's great. Toslink? Toslink, yeah. That's better, yeah. It's Spitus. It's not going to give you, you know, it's not the best in the world, but it'll work. Yes, sir.
So isn't it true that the only way you can get the latest surround formats is over HDMI? You
That's
can't
true.
get that through SPDIF.
Cannot get that through SPDIF, right. So if you want the latest audio, you can't get it through SPDIF or Toslink. Great. Okay, let's move on because we're going to bump into someone else. How are eyes made? This is a little thing I call the birth of an eye. How do they make these eyes? Very simple. See, we have a 0, 0, 0, right? That's a 3-bit word. 0, 0, 0. What does that mean? That's low, low, and low. That's all low. However, if we do a 0, 0, 1, what is that? That's low, low, high. Come on, everybody, let's go. Low, low, high. Low, low, high. Now, if we go 1, 0, 1, we got a high, low, high. Right? High, low, high. Or 0, 1, 0. Low, high, low. Or all ones. What do we get? All highs, right? The Tektronix doesn't give a rat's ass about the numbers. It only cares about the waveforms. It takes those waveforms and puts them together like this. And when they trunk in, that makes an eye. That's how we measure eyes. That's how we make them. And it's the only thing you can use for high-speed data. Here's an example. Video, here we go. Here we have a nice eye over here. 10 meters, what did I tell you, boys? How many dB per meter? 1 dB, so what does that make it? 10. 10's caca. At 3 gigs. Okay. This engine, it's an engine. HDMI is an engine. You have to start it up every time you start it. So here's a nice easy one. Here's we've got a Blu-ray here. We got a display or a preamp. This baby over here, this Blu-ray, I call that something. I call it the queen. The queen. The Blu-ray player rules. Any source rules your system. Your preamp does not. Your speakers do not. Your display does not. They're slaves. The queen rules. So the queen, when you turn the queen on, this is what happens. It produces that 5-volt startup. It wakes it up. So it wakes up your preamp. It wakes up your display. The display turns around and sends Hotplug back. Hotplug comes back, goes into the queen, lights it up. Then the queen pulls out EDID. That tells us what kind of audio, what kind of video, what's the quality going to be. It sends it all the way up to the display. And it asks for its mojo. And all this information is shared. Notice the screen is still dead, by the way. There's no picture yet. After the mojo, it then asks for content protection. This is called keys. So it sends up an HDCP, it goes up and looks for a key. That key is then sent back down. If it matches the revocation list, it goes. Audio, video supplied, you get a picture.
Called the handshake?
No, it's not. The handshake is only the hot plug. No, it's not. That's another fallacy. Everybody get that? Gets worse, people, because guess what? Every 2 seconds, we lost it. That HDCP key is only good for 2 seconds. It needs a new one every 2 seconds. A different one every 2 seconds, and it's got a master revocation list. Everybody get that? Danger. Performance signatures, here we go. Here's a company, let's call it cables. Let's play with cables today, right? Here's a company X cable, performance signatures. This is the DNA. So we have a low video, a kind of okay timer, low DDC, good voltage, and good hot plug. Here's company X. Y, sorry. Good video, poor on the other side. Then we got company Z. We don't see that very often. What happens when you start putting these things together? They all got to work within that HDMI envelope. So what happens? Here's company X. Let's add 2 company X's together. What happens? If we add these together, and they're cables, they're passive, aren't they? They're never going to go up. They're only going to go down. There's no such thing as 100% efficiency. And the longer the cable goes, the worse it gets. So when you put those in the aggregate of each other, the yield only is that. See what happened here? By using 2 cables of this kind of quality, or DNA, it puts your system in a deficit. In this case, the deficit is so bad that it failed. But what? Wait. That's bad juju, right? But what if we were to have company Y and a company X? Ooh, what would that do? It would fix it. Amazing, isn't it? And sometimes those different cables are in the same company because the company doesn't know they came from company X and company Y. These cables, they're bought from all over China. We don't know where they're coming from. So when you take those and add them together, the actual yield ends up being this. So you can actually end up with a much better HDMI overall envelope by mix and matching your DNAs or your performance signatures. This is good juju. So at system level, we could have here's a 3 meter, right? 3 meter gives us what? 3 dB down. Look at the eye. That eye is getting pretty dirty, isn't it? Okay, now we got a coupler over here. Look at the eye in that. It's good. It's only 1 dB down. Add it up. What does it come to? 4. Then we got a 10 meter cable over here. 10 more. Add them up. 14 in the dirt. You're out. Bad juju. You follow me? You got to think about the system environment. Don't think about individual products. That means crap. You got to see how they're going to work within the system environment. It's those products that are tuned and those products that are built to work within that system environment. Bad juju. And in summary, I'm almost done. In summary, what do? Well, we know the interface is pretty complex. This is, by the way, the abridged version of this course. And you got to watch that collective makeup. You got to make sure you got your performance signature right. And, of course, you got to have everything else right in the environment. And when you go to get your performance signatures, how do you do that? Knowledge is everything. So demand these numbers. When you're buying products and you want good, demand that signature. If they don't know it, you better ask them why. Because they either haven't done it yet or they don't even know what you're talking about. And the latter is not good. Unfortunately, that's what you're going to see. And learn and understand how to use that collective. You know, when you start buying cables and seeing how those measurements come through, watch them. You can mix and match and buy them correctly. The better companies, of course, the better companies have gone through our process. And if they go through our process, they're going to have higher performance levels, of course. But, you know, the guys that don't do that, you got to ask them. It's only the guys that are in our group that know what they've got. And if they didn't know it when they got in, they know it now. Because we train every one of those companies. Like in this case, Nordos, because Nordos brought me up here, and I wanted to tell you about that. So we had a little learning thing up there, didn't we, Joe? Up in Boston. We went to Boston and gave them a little kick in the ass. Yeah. And match up all those collectives. And, of course, I wrote a book, by the way. It came out about 3 weeks ago. Everybody wanted to have this presentation, and I just can't do it all. It takes me hours and hours and hours. So I finally put it in book form. I started last year. It just developed. I have a few here at the show. And it tells you everything about HDMI, all the way through HDCP, EDID, HEAC, everything that's going on up to 1.4. And here's my last one. Here we go. Ready for this? All what we talked about today. Here we go. Here's our performance meter. We just dropped it to 80%. See how that got fuzzy? This didn't do anything. The eye pattern got smaller. The frequency response dropped. Let's drop it another 20 points. What happens? This didn't change. Eye pattern got smaller. Frequency response got worse. This got fuzzier. All the way down to 40 now. You see what's happening up here? It's going into the dirt badly, isn't it? But as you go down to the 20 percentile, this hits the dirt. Here's where the audio and the video go to hell. And the next spot, of course, is it's dead. So watch what you're doing with this. All of these performances is quality and reliability. And thank you very much. And the DPL Labs is a resource center. You're more than free to use the website. You can email us if you got questions at any time. And, of course, DPL always brings what? It brings good juju. Thank you very much today.